Hi everyone, this lesson is going to cover absolute value. So it's going to include things about graphing absolute value functions and transformations, key features like domain and range as well. So let's get started. This first page is just a reference sheet for you. Notice the overall shape of the absolute value graph, that red V shape that you see. That V shape is going to be very important in recognizing what the graph looks like. So you should be able to be given a graph, see the V shape, and know this is an absolute value function. Absolute value just means that whatever number you put inside of these vertical bars is talking about the distance from 0. So if I put a -3 in here, let's look at a number line. So here's 0, here is -3. I am 1, 2, 3 units from 0. So the absolute value of -3 is 3. The way that some people remember it is that whatever number comes out of the absolute value bars is always going to be positive. So like if I said the absolute value of 2, that's asking how many units away from 0 is 2. Well, it's 2 units away. So any number that comes out should always be positive, and it's asking you how far is that number from 0. Distance is never negative. That's why whatever comes out is always a positive number. Okay, now let's take a look at the key features of it. There is a QR code for another video link if you want to check that out. I'm going to go over the same thing, so your preference of which one you want to watch. Okay, so these two, we're going to be looking at domain and range. This is the absolute value function because it has that V shape on the graph. This is asking what is the range of the function. So range looks at the graph from the bottom to the top. So the bottommost point of this graph is right here. And then the top, well, we don't know where the top is because there's arrows at both ends of this. So we're going to say that it goes all the way to infinity. Range also looks at y values. I'm not looking at the x values, I'm looking at the y values. So the starting point is at 0, and then all of the values are going to continue to move up and go to infinity. So we can either write this as 0 to infinity, or I can say this is going to be the set of all y values such that all my y values are bigger than or equal to 0. So I'm going to choose this answer choice right here. Okay, on the next one, it's asking about domain. The domain looks at the graph from the left to the right. So I'm looking, this is the left side, this is the right side. Notice that my graph has arrows on both ends. So that means it's going to go on forever in the left direction, and it's going to go on forever in the right direction. The domain of every single absolute value function is always going to be negative infinity to positive infinity, or I can also say that is all real numbers. So looking at the x values, all the negative x values are going to work, and all the positive x values are going to work. So thinking about domain and range a little bit differently than just looking at the graph, the range of a function is all of the possible outputs. So the outputs are the things that I get as my answers. The only answer I can get from an absolute value question is a positive number because everything that comes out of absolute value is positive. That's why the range, when you're looking at this graph, goes from 0 to positive infinity. I'm not going to include any negative numbers because my answer can't be negative. The domain looks at all the inputs, and I can put any number that I want to, positive or negative, inside of an absolute value bar, and I'm going to get something that's positive in return. So I can input a positive or a negative number. That's why the domain includes all the negative numbers and the positive numbers. Okay. The equation for the function above is just y equals the absolute value of x. Why is it a function? So let's talk about the vertical line test. Testing if something is a function means that for every y value, you only have one unique x value that's mapped to it. So that means if I draw a vertical line through my graph, it should only go through every point one time. So if I do that, and I start drawing vertical lines, I'm only hitting the graph at one point. That means that this is a function. For example, I'll draw a circle. That's an ugly circle, but deal with it. So if I draw a vertical line through that circle, it's going to touch 1, 2 times. A circle is not a function because the vertical line test fails. It touches 2 points on that one line. An absolute value function is a function because it only goes through one time. So where it says, why is it a function? We're going to say passes vertical line test. Okay. If the graph were to open downwards, what would the equation be? So usually the absolute value graph looks like this. It's facing upwards. If I make it point downwards, it's now opening like this. What that's doing is reflecting the graph over the x-axis. Thinking back to transformations, a reflection over the x-axis causes a negative sign to be in the front of my function. So this reflect over x-axis. If your graph is pointing downward, you're going to have a negative sign in front of the absolute value symbol. Okay, let's look at a transform graph. So the range of this function, I'm going to answer this question here. The range of this function, my lowest point is still 0, and I'm still going to go to all of the positive y values. So my range is going to be 0 to infinity, or you can say the set of all y values such that y is bigger than or equal to 0. Okay. The domain of the function, remember that I can put in any number that I want to. I can put in all the negative values and all the positive values. So this is still going to be all real numbers. What is the equation of the function? So this is the tricky part. If you print it out, you might not have like the grid lines that look like this. So just know that that's what it's supposed to be. Your vertex here, this is at -7, 0. And then let's talk about, I guess you can call it slope. It's really not the slope, but your slope is still going to be rise over run. So I'm going to be rising. Let's pick another pretty point. Let's pick this one right here. I'm going to be rising 1, 2, 3. And I'm going to be running 1. So my slope is 3 over 1, or we can simplify that down to just 3. So that number is representing your A value. So let's go back over here for a second. So the pieces I need are my A value. We said that was 3. H and K are the points from your vertex. So the -7, that's your H value. And then your K value is 0. So this is -7, this is 0. My general equation is A absolute value of x minus h plus k. So I'm just going to substitute. A is going to become 3. I'm going to leave x alone. H is -7, but be careful. Remember that x lies when you're looking at a graph or the equation, the sign is flipped. So this is going to become +7. And then plus k is +0, but we don't really need to write that because adding 0 to something doesn't change it. So your equation is just going to be y equals 3 times x plus 7. You don't need to put the +0 in the back. We're not going to do the part that says pre-AP extension. That's for the pre-AP kids. Okay. So that is your quick little video tutorial over the key features of absolute value functions. If you have questions, please let me know.